The 1960s, a decade of dreams and possibilities beyond Earth, saw the United States and the Soviet Union locked in a fierce rivalry to conquer space, culminating in the formation of NASA and the birth of Project Apollo. Apollo 11's success in 1969 set a high bar, but Apollo 13's near-catastrophic explosion highlighted the perils of space travel, casting a shadow over the upcoming Apollo 14 mission. Commander Alan Shepard, Command Module Pilot Stuart Roosa, and Lunar Module Pilot Edgar each brought unique expertise to Apollo 14, undergoing rigorous training for their lunar mission. Apollo 14 aimed to explore the Fra Mauro highlands, using advanced scientific instruments to study the moon's early history and composition, even carrying tree seeds for a unique Earth experiment. On January 31, 1971, the world watched as Apollo 14, atop the mighty Saturn V rocket, launched from Kennedy Space Center, embarking on a mission to test human courage and ingenuity. As Apollo 14 journeyed through space, the crew experienced weightlessness and the shrinking Earth, meticulously planning and adjusting their trajectory for the crucial lunar landing. Approaching the Moon, Apollo 14's crew executed precise maneuvers to enter lunar orbit, with Roosa piloting the command module and Shepard and Mitchell preparing for their descent in the lunar module Antares. As Antares neared the lunar surface, an abort signal threatened the mission, but the crew's calm response and mission control's ingenuity led to a successful workaround, allowing the landing to proceed. On February 5, 1971, Apollo 14's Antares successfully touched down on the Moon, overcoming a critical technical glitch and setting the stage for lunar exploration. Shepard and Mitchell, the fifth and sixth humans to walk on the Moon, planted the American flag and began their scientific exploration of the Fra Mauro highlands, collecting samples and deploying experiments. Apollo 14's mission focused on scientific discovery, deploying the ALSEP to study the Moon's environment and collecting valuable lunar samples, including the famous Big Bertha rock, while also finding time for a light-hearted golf experiment. The lunar surface, a tapestry of craters and dust, stretched out before Shepard and Mitchell, their mission to reach the rim of Cone Crater, a significant geological feature formed by a meteor impact eons ago. Scientists back on Earth eagerly awaited the samples and data that would be gathered from this unique location, hoping to glean insights into the Moon's violent past. Equipped with their lunar rover, a rudimentary but essential vehicle for navigating the undulating terrain, Shepard and Mitchell set off towards Cone Crater. The rover, nicknamed the Modularized Equipment Transporter, or MET, bounced along the lunar surface, its large wire mesh wheels leaving distinctive tracks in the moon dust. As they ventured farther from the lunar module, a sense of isolation washed over them. The landscape, though breathtaking in its stark beauty, was utterly alien, devoid of any familiar landmarks. The sun, hanging low in the lunar sky, cast long, eerie shadows, obscuring craters and boulders, making navigation increasingly difficult. To make matters worse, their communication with Mission Control grew increasingly sporadic. The rolling terrain and the limitations of their radio equipment conspired to create frustrating periods of static and silence. They were, for all intents and purposes, alone on the lunar surface, their lifeline to Earth reduced to a faint whisper. The astronauts, despite their rigorous training, began to feel the pressure. They were lost in a maze of craters and ridges. Their objective, the rim of Cone Crater, seemingly farther away with each passing moment. Time, a precious commodity on a lunar EVA, was slipping away. Back on Earth, the mood in mission control mirrored the growing concern on the lunar surface. The telemetry data from the lunar rover showed Shepard and Mitchell veering off course, their progress hampered by the challenging terrain and the communication glitches. The team watched anxiously as the clock ticked down, each passing minute bringing the astronauts closer to the limit of their oxygen supply. Flight Director Jerry Griffin, known for his calm demeanor and sharp decision-making, rallied his team. They had encountered problems before. Apollo 13's near disaster was still fresh in everyone's minds, and they had always found a solution. This time would be no different. Engineers huddled over maps of the lunar surface, comparing the rover's trajectory with the planned route. The challenge was to find a way to guide Shepard and Mitchell back on course, using only the limited communication available. They needed a solution that was simple, easy to convey, and could be implemented immediately. After what felt like an eternity, a solution emerged. The engineers realized that the astronauts could use the sun's position in the lunar sky as a navigational aid. By aligning the shadow cast by the lunar module with a specific landmark on their maps, they could reorient themselves and plot a course towards Cone Crater. The instructions, relayed to Shepard and Mitchell during a brief break in the static, were met with a mixture of relief and determination. They now had a fighting chance of reaching their objective, of salvaging this crucial aspect of their mission. Armed with a renewed sense of purpose, Shepard and Mitchell corrected their course. They used the lunar module's shadow as a guide, making their way back to their target. Finally, they reached their destination. The view from Cone Crater's rim was breathtaking. Despite exhaustion, they felt awe and accomplishment. They had overcome the lunar challenges and emerged victorious. Apollo 14 was a resounding success. Back on Earth, anticipation crackled in the air. Apollo 14's safe return, a triumph over technical glitches and navigational challenges, brought with it a treasure trove of scientific data and lunar samples. The world, captivated by the mission's drama and success, eagerly awaited the unveiling of the moon's secrets. The lunar samples, meticulously collected and catalogued by Shepard and Mitchell, were like messages from an alien world. Under the scrutiny of powerful microscopes and sophisticated analytical instruments, these rocks and dust began to tell their story, a story billions of years in the making. Scientists, their eyes wide with wonder, peered into the moon's distant past. The samples revealed a history marked by cataclysmic impacts, volcanic activity, and a slow, relentless bombardment by cosmic debris. The Fra Mauro highlands, once a blank canvas in our understanding of the lunar surface, sprang to life as a dynamic and complex geological region. The analysis of the Genesis rock, as it came to be known, sent ripples of excitement through the scientific community. This single rock, retrieved from a crater rim, provided compelling evidence that the moon, far from being a cold, inert body, was once a hot, molten world, its early history intertwined with the formation of the Earth itself. Apollo 14, beyond its immediate findings, laid the groundwork for a deeper understanding of the moon. The mission's success, coupled with the wealth of data it provided, energized lunar science, paving the way for future missions and a renewed focus on unraveling the mysteries of our celestial neighbor. The scientific legacy of Apollo 14 extends far beyond the lunar samples and the stunning images beamed back to Earth. The mission, through its meticulously planned experiments, provided crucial insights into the moon's environment and its interaction with the space environment. The LSEP, deployed on the lunar surface by Shepard and Mitchell, continued to transmit data back to Earth for years after the astronauts had returned home. This silent sentinel, powered by a nuclear battery, became a remote outpost for lunar science, providing invaluable information about moonquakes, the lunar heat flow, and the interaction of the solar wind with the lunar surface. The seismometer, a key component of the ALSEP, detected vibrations within the moon, revealing a surprising level of activity beneath its seemingly inert surface. These moonquakes, caused by the gravitational pull of the Earth and the slow cooling of the lunar interior, provided clues about the moon's internal structure and its evolution over billions of years. Another experiment, the Charged Particle Lunar Environment Experiment, or CPLEE, measured the energy and direction of charged particles reaching the lunar surface. This data provided valuable insights into the solar wind, a stream of charged particles constantly flowing from the sun, and its interaction with the moon's magnetic field, or lack thereof. Apollo 14's scientific endeavors, though often overshadowed by the drama of the mission itself, were a testament to the power of meticulous planning, innovative engineering, and the insatiable human desire to understand the cosmos around us. Apollo 14, the third successful lunar landing mission, marked a turning point in our exploration of the moon. With each mission, with each step taken on the lunar surface, our understanding of our celestial neighbor grew, pushing back the boundaries of human knowledge and challenging long-held assumptions. The mission's success, coming on the heels of the near disaster of Apollo 13, restored confidence in NASA's ability to safely send humans to the moon and return them safely to Earth. This renewed confidence, coupled with the scientific treasures brought back by Apollo 14, paved the way for future lunar missions, each more ambitious and scientifically sophisticated than the last. Apollo 14's legacy extends far beyond the immediate results of the mission. It ignited a passion for lunar science that continues to this day, inspiring generations of scientists and engineers to unravel the remaining mysteries of the moon. The mission's impact can be seen in the ongoing research using the lunar samples, in the development of new technologies for lunar exploration, and in the renewed interest in sending humans back to the moon. Apollo 14, a testament to human ingenuity, courage, and the relentless pursuit of knowledge, stands as a beacon in the history of space exploration, a reminder that even in the face of adversity, the human spirit, driven by curiosity and a thirst for discovery, can overcome any obstacle, reach for the stars, and unlock the secrets of the cosmos. Apollo 14 was more than just a mission. It was a testament to the enduring human spirit. The crew's courage and ingenuity in the face of challenges echoes through time. They explored its mysteries, planted seeds of hope, and paved the way for future generations. Apollo 14's success pushed the boundaries of human knowledge. The mission's scientific discoveries continue to shape our understanding of the cosmos. Every small step contributes to a giant leap for mankind. Apollo 14's legacy lives on in the annals of space exploration history. It serves as a beacon for those who dare to dream of reaching for the stars. The spirit of Apollo 14, a spirit of resilience, ingenuity, and unwavering curiosity, will continue to light our way.